In this video, we're going to talk about area between curves. So you've already learned how to decide, when the integration matches the area. I can't even talk. How about area? All right. So supposedly you know how to find the area between a curve and the x-axis. So we're going to kind of broaden that a little bit. All right. So let's pull up this PowerPoint, I hope. Okay, and see if we can kind of get started. And I think this will help you on your test. Okay, area between curves. All right. So we're going to kind of expand it, but we're going to kind of start with what you know and move to what you don't know. Okay, now think about it. Do we understand? Let's see if I can get my little pointer as usual. Okay, if I integrated from A to B on f of x, wouldn't that give me the area? Since this f of x curve is the whole thing is above the x-axis, wouldn't that give me the area from the x-axis down, from the f of x down to the x-axis? That'd give me that area right there. All right, do we agree? All right, so since this entire f of x curve is above the x-axis, then if you integrate from A to B on f of x, that's the area from f of x down to the x-axis. Now, what I really want, though, is this area between f of x and g of x. So do you see what I'm about to try to do? What would happen if I integrated from A to B of g of x? All right, so on that red curve. All right, do we understand that that red curve is also above the x-axis between A and B? So if I did that integration, wouldn't it be this area right here? Okay, between that red curve and the x-axis. Okay, so if this integration right here, all right, gives me this area from f of x down to the x-axis, and this integration right here gives me the area from g of x down to the x-axis, how could I use those two things, like the area from here down and then the area from there down? How could I use that to get the area between the two? Okay, do you see what I would need to do? All right, let's see if we agree. All right, couldn't I subtract the two? Couldn't I take the area from here all the way to there? All right, and then find the area from there to there. And then if I subtracted those two, wouldn't that give me that penciled area that I wanted? Okay, does that make sense? Now, I kind of want to show you something. So I need you to kind of write, make sure that you're pausing the video and taking notes and putting your examples down there, but see if this one makes sense to you then. All right, if you want to find the area between two curves, f of x and g of x, you're going to find the area, you're going to integrate f of x and then g of x and then subtract the two. Okay, now let me kind of go back here and make sure that this makes sense with what we talked about that seemed to be confusing a few of you. All right, let's see if I can get my little pointer back. So do you see that if your entire curve was above the x-axis, and I'm just going to call that f, like f of x, all right, if you wanted the area between there and the x-axis, all right, that's why it matches. All right, so from A to B, that integration, like if this was my A and this was my B somewhere over here, then if I integrated, that would get me all of that area right there. And the reason is this, we're going to talk about this in a second, but it's the curve on the top, that'd be f of x, minus, and the curve on the bottom would be 0. All right, so that's why when the curve was above the x-axis, the integration was the same thing, because subtracting 0 wouldn't change anything. Okay, now what if you had this instead? What if your whole curve was below the x-axis? So again, here's your A. Looks like a U. Let's see if we can make it look more like an A. and here's my B, and my F is down here. All right, and again, I wanted this area. All right, now think about it. Again, it would be A to B. All right, it's hard for me to type, but it'd be A to B. But this time on the top, that would be 0. And then minus, because it's y, f of x equals 0. That's your y-axis, right? F of x equals 0 is just another name for it. Minus your curve on the bottom. And then your dx. So think about what that would give you. All right. So does it make sense then that 0 minus f of x would just give you a negative f of x? All right. So that is why, let's see if I can get that thing to do again. So that's going to be why when your whole curve is below the x-axis, remember we said the area was the opposite of that integration. Because remember, I can take that negative and I can pull it in front. All right, so that's what we've been saying the whole time. Only I think this makes it a little easier to see why it's true. All right, so when your whole curve is above the x-axis, the integration just matched the area. And that's why when your whole curve was below the x-axis, the area was the opposite of the integration. All right, but now with this kind of new way of looking at it, this new formula, I think it's going to make your life a whole lot better. Okay, because you don't really have to worry about where the curve is anymore. Okay, so look what it says. When you want the area between two curves, f of x and g of x, on an interval like 1 to 5 or a -0.5 to 11 or whatever, as long as your curves are continuous, and as long as f of x is above g of x, then the area of the region bounded by all four of those things is just the difference in those integrations. Now we're going to work a whole bunch of these and kind of set them up. All right, you can finish them on your own because a lot of them end up being pretty simple power rules. But this is the part I need you to really write in your notes. All right, because if you don't learn to do this now, when we get to volume next, I'm going to really lose you. Okay, so the first thing you're going to do when you're trying to find areas, you're going to grave all the curves. And my advice to you is get some colored pencils. It's going to make your life infinitely easier if you've got colored pencils. Okay, especially if you're a visual learner. So when I'm on the whiteboard next week, you're going to see me switching colors every time I draw a different graph. Okay. Then you're going to do what's called a representative rectangle. You're either going to draw a vertical rectangle or you're going to draw a horizontal rectangle. Now, most of the time, people like vertical rectangles, and I understand that. And you can use a vertical rectangle almost a majority of the time, but there are going to be times when you need to use a horizontal rectangle, and I'll show you one in a minute, or you would choose to do that. Okay. But depending on how you draw your rectangle, that tells you whether you have to use dx or dy. If your rectangle is vertical, you have to do dx. And if your rectangle is horizontal, you're going to have to do dy. So if I'm doing dx, that means this a and this b are x numbers. If I'm doing dy, that means this a and this b are y numbers. So it only has to do with which way your rectangle is turned. Vertical's dx, horizontal's dy. All right. If it's a vertical rectangle, then the way you get the integrand is you do the y on the top minus the y on the bottom. You'll see what I mean in a minute. If it's a horizontal rectangle, you're always going to do x on the right minus x on the left. So this switches. If you're doing dx, y on the top minus y on the bottom. If you're doing dy, x on the right minus x on the left. So copy that down and then have it beside you when we go to the next slide. So you can kind of see what I'm talking about. All right, so let's go work some so I can kind of explain it to you. All right, here's what it says. It just says set up the integrations. I'm assuming that you can finish them, okay, because these are super duper duper simple. The hard part is setting them up. The hard part is not doing the integration, Okay, because if you set the integration up incorrectly, your answer is going to be wrong. And there's not really much partial credit for setting it up wrong and then getting the answer for that integration, which is not the answer you wanted. Okay, it's like me telling you to go to Memphis and instead you go to Biloxi. I mean, good job, you got to Biloxi, but that's got nothing to do with what I told you. Okay, so the same kind of thing. You have to find the area that I tell you to find. Now, here's what you'll start seeing me do on the board. All right, it says set up the integrations to find the areas bounded by. So one of your fences, one of your boundaries is y equals x squared, that parabola. So I drew it in one color and I even boxed it in that same color so I wouldn't get lost. Another boundary is y equals 0. Okay, so you know y equals 0 is another way of saying just your x-axis. So I'm gonna kind of do it in this color so it's blue. Okay, so I'm trying to, it's really on the x-axis up there, but I'm trying to make sure you see it. Okay, then you have to go x equals 1 to x equals 4. So I've got to be bounded by, that's kind of hard to see. It's kind of a blue and a black and this bright blue and this pink. So I shade the part that's bounded by all of those. Okay, now once I get my shading, all right, once I get my shading, then I draw a rectangle. And most of you are going to want to draw them vertical most of the time. So if it's a vertical rectangle, the first thing you would have seen me do is this. As soon as I draw a vertical rectangle, I'm going to come out here and write down dx. And it's dx because they're vertical rectangles. Now, if it's dx, these have to be x numbers. So look at your shading from your smallest x to your biggest x. Well, remember, this was x equals 1 and that was x equals 4. So I'm going from 1 to 4. So the first thing you would see me do, if you were watching me do it at my desk upstairs, is I would either put dx or dy and put those numbers. So if it's dx, these are x numbers on the shading. If it's dy, these would be y numbers on the shading. Now, remember from that slide back here, they're supposed to be next to you. If it's dx, you're supposed to do y on the top minus y on the bottom. Now, why can't you say y? All right, why can't you say y? Well, the reason you can't say y is you can't mix variables. So if it's dx, everything here has to be x. So when I say y on the top, I mean y on the pink. So I try to find which graph was the pink one. See, that's why I boxed that one in pink or write it in pink. On this graph, the y is really x squared. So instead of writing y, see, I wrote x squared because the y on the pink is x squared minus, and then again, what's the y on the bottom? Well, on that blue one, that's your y value. Y is 0. So see, the y on the pink and the y on the blue. So that's why color coding is going to be helpful. Y on the top minus y on the bottom. And no matter where you drew the rectangle on that shading, it would be pink on the top and blue on the bottom. And that's going to be real important to notice. So all you've got to do is integrate x squared. So of course you're going to get x cubed over 3. All right. And then you're integrating from 1 to 4. So of course you'd substitute in your 4 and have 4 cubed. So 4 times 4 is 16. 16 times 4, so I'd have 64 thirds. All right. And then minus. And then I'd plug my 1 in there and have 1/3. So what's that going to get me? That's going to get me 63 thirds, which is 21. So the answer to that area is 21 square units. So that's what I mean by the integrations are simple. It's the setup that you've got to be careful with. Okay, now let's do another one. All right, look at this one. Here's your boundary, y equals x cubed. So I drew it in pink. So there's that pink graph. All right, y equals 0. All right, y equals 0 is another way of saying the x-axis. All right, so I'm going to kind of do it in that blue color. All right, and x equals a -3 is that vertical black line right there. So I've got to shade what's between that black, that blue, and that pink. So that ends up being this shading right here. See, over here, it's not bounded by anything. It's unbounded. Up here, it's unbounded. Down there, it's unbounded. It's got to be bounded. Cows can't get out. Okay, country girl here. Cows can't get out. All right. Now, you got to decide how you want to draw your rectangle. If you draw it vertically, it's got to be dx. So again, remember what I said. As soon as I draw the rectangle vertical, I'm going to come over here and write down dx. And if it's dx, I have to look at the x's. So my shading goes from here to there. So that x is a -3, and that's the point 0, 0. So that's why I went -3 to 0. Now, you got your little paper beside you. If it's dx, it's got to be y on the top minus y on the bottom. But I can't put y because it's got to be x's. This time, the y on the top is this bright blue. So the y on the top is where I got the 0. Minus. And then I've got the y on the bottom, so the y on the pink. But the y on the pink is x cubed minus x cubed. So do you understand what you're really going to be integrating? All right. So if I've got my x cubed here. All right. Well, 0 minus x cubed is going to be a -x cubed. And then what can I do next? Can I just pull out, oops, come back. Can I just take this negative and pull it out? So I'm really going to be integrating just the opposite of x cubed. So I'm going to get x to the 4th over 4. But I'm going to have a negative in front of it. Okay, and I'll plug in my 0 and then plug in my -3 and then subtract. So the integrations are simple. Okay, you just got to be careful when you're setting them up. All right, let's go look at a few more to make sure that we're clear. All right, look at this one. This time I say, set up the integration and I want it bounded by these two graphs. So y equals x cubed is that pink parabola again, and y equals 6 minus x is just a line. So it's got to be between the pink and the blue. So that's this shaded area right here. See, this is not bounded. That's not between them. There's no end. That's not bounded. It's this shaded area right here. So first make sure that your shaded area is right. Then draw yourself a rectangle. So if you draw it vertical, again, it's got to be dx. So that means these have to be x numbers. So what in the world am I going to do? You can't just go, well, it looks like. I mean, here's one of your x values, and here's one of your x values. But now, I want to show you this just to show you how weird it can look sometime. See, if I were guessing, that looks like the 0.4 or something, because this is a really, really, really rough sketch. Okay? So I need you to be real careful. Don't look with what it looks like. You've got to algebraically do it. So here's what I did. I said, okay, if I'm doing a rough sketch, it can be way off, and this one's way off. That parabola is way too wide. It should be much more steep. Okay? So I've got to know what these points are exactly. So notice this blue point's on the red curve, the pink one or whatever, and on the blue one. So that means the x on the red's the same as the x on the blue, and the y on the red, same thing as the y on the blue. So what I did was I set the y's equal to each other. I said the y on the red equals the y on the blue. But I substituted in because they both say y equals, that seemed easier. So I plugged in this for the y on the red, and I plugged in 6 minus x for the y on the blue. Well, that's a quadratic equation. How do we solve a quadratic equation? Don't we put everything on one side and factor? So I did. So that's going to make that a plus x and a minus 6. So when I factor, double check, x times x is x squared. That's going to be a minus 2x, and a plus 3x does give me a plus x. So my solutions were -3 and 2. So that doesn't even look like the 0.2 something, but it is the 0.2 something. Okay. Now, if I needed it, I could get the whole point, okay? So that is 2 comma something. All right, this point up here is a -3 comma something. Okay. Now, how would I get these y parts if I knew them? Couldn't I plug them in my original? It wouldn't matter which one I plugged them into. But I don't need them because these are dx's, these are x numbers. So the smallest x over here is a -3, and the biggest x, the furthest one on that shading, is a 2. So that's how I got -3 to 2. And remember, when it's dx, it's y on the top minus y on the bottom. So y on the blue minus y on the pink. All right, so do you see why color coding is going to be real important? Y on the blue. So that's how I know to put 6 minus x first, and make sure you put it in a parenthesis. Minus, and then your y on the bottom is going to be the y on the pink. So the y on the blue minus the y on the pink. So you're going to end up having 3 little things. You're going to be integrating 6 minus x squared. So a bunch of little power rules. Then you're going to substitute in 2 and substitute in -3 and get a number answer. Now think about it. You can't get a negative area. You get a negative answer, you know it's not right. Area can't be negative. Now, look at why color coding is, again, super important. The pink graph is y equals 3x cubed minus 3x. So it looks like this, up, down, up looking curve. And then y equals 0 is your x-axis again. Well, here's my problem. I'm going to have to do 2 different integrations. I'm going to have to find this area separately from this area and then add them. Because when I draw my rectangles, do you see that on the top here is red, on the top here is blue? So if it switches on you, you've got to switch integrations. So again, I thought that looked like the point 0, 0, and I couldn't tell if that was, if that's point, if that's -1.01, you're not going to be able to tell it. So you've got to algebraically do it. And again, I did the y on the red equals the y on the blue. So the y on the red was 3x cubed minus 3x, and the y on the blue was 0. I factored out that 3x, and then x squared minus 1 factored more into x minus 1 and x plus 1. So if 3x is 0, that means x is 0. If x minus 1 is 0, that meant x was 1. I solved x plus 1 for 0 and got -1. So apparently right here, okay, let me go get my marker again. Right here, that's going to be the point -1 comma something. That right there is going to be the point 0 comma something. And this point right here is going to be the point 1 comma something. And again, you can go get those other values if you want to. If you plug a 1 in there, you're going to get -1, 0, 0, 0, and 1, 0. So I drew a vertical rectangle, so that's how I knew it was dx. Right here, it goes from -1 to 0, -1 to 0. It's y on the pink minus y on the blue. So y on the pink was the 3x cubed minus 3 minus the y on the blue is 0. Then when I did this one, it switched. My y on the top was the y on the blue. So 0 and then minus, and make sure you're putting things in parentheses. The y on the bottom is going to be the y on the pink. So 3x cubed minus 3x. If you don't have that parenthesis, this sign right here is going to be wrong. Okay, so I have to do these 2 integrations and get those answers and add those answers up. Now, what I want you to try on your own is if you just integrated from -1 to 1, your answer would end up being 0. Which you know is not right. That shaded area is not 0. You got shaded area. And the reason we talked about way last time is this: if you just go straight and part of your graph's above and parts below, the reason it's 0 is, remember, the integration is the difference in the 2. So when things change, if you want the area, you're going to split them up into more than one integration. Now, sometimes you can avoid splitting them up. Let me show you one. Here, I could not avoid it. I'd have to split it up. Okay, but let me show you one where sometimes you can avoid it. All right, look at this one. Here's my graph. G of y is 3 minus y squared, and f of y is y plus 1. Now remember, g of y is another way of saying x, and f of y is another way of saying x. Now, if you want to graph this one with your grapher, you're going to have to change it. All right, this one is x equals 3 minus y squared. So, for you to use your grapher, you've got to make it say y equals. So do you understand that that would be y squared would equal 3 minus x if you moved everything around? All right, so if you move that over there and you move that over there, well, then how would you solve for y? Well, a lot of you would make this mistake. You would think that that's just the square root of 3 minus x, but it's not. It's a positive or negative. So what's happening is the top half, like from here to there, that's y equals the square root of 3 minus x. And from here down is y equals the negative square root of 3 minus x. So if you want to graph this with your graphers, you're going to have to graph two different things. You're going to have to graph y is the square root of 3 minus x. And what that's going to do is it would graph the top half of that parabola. And then separately, you're going to have to graph y equals a negative and then square root of 3 minus x. And when you did that, that would graph the bottom half of your parabola. Or you can just make a t-table and do it yourself. Now, look what I did this time. I drew the rectangle horizontal, and here's why I did. Do you see, no matter where I draw that horizontal rectangle, that I've got pink on the right and blue on the left? Now, we're going to talk about that in just a second. But remember, if I draw a horizontal rectangle, I've got to do dy. So if I do dy, these have to be y numbers. So again, I've got to know what these intersection points were. They did not give those to me. Okay, so I had to do the same thing, but instead of saying y on the pink equals y on the blue, this time I said x on the pink is x on the blue. Okay, and then look up here. What's the x on the pink? Well, it's 3 minus y squared. What's the x on the blue? Well, the x on the blue is y plus 1. And then again, I had a quadratic equation, so I pulled everything to one side and I factored it. And when I factored it, my y came out to be a -2 and a 1. So I know the y coordinate down here is a -2. I don't know what the x coordinate is. Now I could figure out it's 1 by plugging in right here. Okay, but I don't need it. All right, here my y value is a +1. So if it's dy, these have to be y numbers. So my lowest is a -2, my highest is a 1. So that's how I got the A and the B. Now, back up here, remember you have to have that sheet next to you. If you're doing dy, it's not y on the top minus y on the bottom. It's x on the right minus x on the left. So x on the pink. Remember, this is the same thing as x. And I can't put x because it says dy, so it's got to be in terms of y. So on this pink, my x is the same thing as 3 minus y squared. Minus, and then on the blue, my x is y plus 1. So when it's vertical, dx, y on the top minus y on the bottom. When it's horizontal, it's dy and it's x on the right minus x on the left. Now, you may say, well, I'm just going to do them all vertical. No, you're not. Look at why. Do you understand that on this graph, if you draw it vertical, all right, if I drew it vertical right there, do you see that I would have blue on the top and pink on the bottom? When I get over here though, if I draw it vertical, I've got pink on the top and pink on the bottom. So what I could do is look and see where it changes. You know, before I get to this dotted line, it's blue on the top and pink on the bottom. And that's the 0.21. So if I wanted to do a vertical rectangle, I could, but I'm gonna have to have two different integrations. So this X value, remember I told you I could figure out it's a -1 if I needed to by just plugging in one of these up here. So it's -1 to 2, -1 to 2. And it's Y on the blue, excuse me, it's Y on the blue. So Y on the blue one is that line X minus 1. And then it's going to be minus. All right, now where did I get this plus? Well, remember this Y on the bottom was this one. Okay, it's this one. So I've got minus a negative, and minus a negative is plus a positive. I did the same thing over here. Over here, I've got Y on the top. So that Y on the top there is that positive root minus this Y on the bottom would be that negative root. So again, I would have plus a positive over here. So do you want to do this integration or do you want to do these two integrations in Atom? So you're mostly going to draw vertical rectangles, but sometimes a horizontal rectangle is going to be super handy. It's going to make your work a whole lot easier. Okay, so make sure that you're good to go on those things. Okay, go back up here. So again, to me, this is the part that's key, is knowing this thing down here. If you draw a vertical rectangle, it's dx, and it's going to be y on the top minus y on the bottom. If you draw a horizontal rectangle, it's going to be dy, and it's going to be x on the right minus x on the left. Okay, so I hope that helps. Now that's really going to be on test 2, but if I ask you to do an area problem, you could even use it on test 1. Okay, so try that homework and let me know if you need any help.